Hey everyone, in this video I want to take a look at finding another type of confidence interval. In this case we are specifically looking at proportions. For example, in this question someone wants to figure out what percentage or what proportion of oil tankers spill each month, and in order to do that they went out and took a sample of 563 of these oil tankers and found out that 445 didn't have a spill. So keep in mind as you look through this that when we see the difference between P and P hat, this is the proportion of the population, which we don't know. We're trying to figure this out. What we do know is the proportion of the sample that we drew. In this case, out of 563, 445 did not have spills. Now keep in mind they wanted to figure out the proportion of ones that actually did have spills. So I'm just going to quickly say 563 minus 445, I end up with 118. 118 oil tankers out of this sample did have a spill. So my sample proportion is 118 out of the 563 drawn, or about 21%. Now, that part is just figuring out the proportion. We are going to use a couple of formulas. A few of them are review from previous sections where we are going to put this together to come up with a confidence interval. Now, the confidence interval by itself looks like this. You're going to take that sample proportion plus or minus a critical value. You call these from last time the critical value that you're looking for based on, in this case, we're going to be looking for one that's 98%, times the standard deviation of that population. Now, when we are working through this, we are going to have to find that standard deviation. Recalling from earlier sections, the standard deviation, when you're working with a proportion like this, the square root of the two different proportions. In this case, on one side we have 21%, and then one minus that, everything else, the complement, 79%. And we're going to divide that by the number of people in the sample. In this case, 563. So that part is going to take care of this. So all of this right here becomes that value. For the critical value, since we're looking for a 98%, we would typically use some sort of chart like the one that I have here and say like, oh, here's a 98% critical value. They never change. Is going to be for a z-score 2.33. So I am going to use this 2.33 right here. And I already found the sample population, or the sample proportion of the population, that 0.210. So it's taking all of this and putting it together in order to come up with that confidence interval. So I am going to start with 0.210 plus or minus 2.33 times whatever this ends up, and I need to crunch the numbers for that. I come up with for this approximately 0.0171, so I'm going to round it off there. So I have that times 2.33, and I'm going to add that to 0.210. So on one side over here I've got 0.24999, it's going to keep going. And on the other side I have to take this 0.210 minus 2.33 times 0.017. And I have over here 0.17039. Rounding those off, I'm going to say from about 17% all the way up to 25%. 98% confidence interval would get me into that range from 17 to 25%. So remember what this means. If we were to go out and do this survey, I'm saying that 98% of the time, the survey result is going to be between those two numbers, right? I'm going to get a survey every once in a while where my range or the actual population proportion is going to be lower or higher than that. Now, the other thing that we often have to do is come up with the sample size. Like, how big does a sample size need to be in order to get a proportion with some sort of error? So I'm going to write down that formula right away. The minimum sample size is going to be, working with some of the same things, I'm going to take that critical value, the two-tailed, I'm going to have to square that, multiply it by the proportion, and 1 minus the proportion, just like we did in that last section, and I am going to divide it by the error squared. So let's look at a problem that does this. So here in this problem, NASA's doing an experiment. They want to see who passes out at G-force larger than 6. They did an earlier study, and they estimated the population proportion to be 0.5. They want to know how large a sample would be required to estimate the fraction of people who black out at 6 at a 99% confidence interval with an error of at most 3% here. So, looking at all of these things, the parts that I need to know in order to find out this sample size is going to be one thing, what critical value am I going to use? So I'm going to pull over my critical value table again, because they want a 99% critical value. All right, so the 99% critical value is not the one circled here. So let's get rid of this. They want to find 0.2575. So I'm going to need n equals 2.575, make sure that that's squared, times the proportion, both the positive and negative, or the complements. In this case, since it's 50%, I'm going to have 50% or 1.5 and 1 minus 0.5, so I have both of those, divided by the error that they're interested in, 0.03, that is also going to be squared. So I'm going to crunch these numbers and come up with the sample size that they need. All right, throwing these in the calculator, I came up with 1841.84. Now, remember that when you're working with sample sizes, you can't have a decimal of a person, so you always round up. This is going to be 1,842 people. So if I want to do this, I am going to have to use 1,842 people in that sample size. So hopefully that will help you use basically the same formulas. Remember that no matter what you're doing with population proportion, you're going to need a critical value of z to figure out the percentage in both of these formulas. In this case, I was doing two-tailed numbers because confidence intervals, remember, both tails. In that confidence interval, you're also going to need that standard deviation formula, where square root of the proportion for, the proportion against, divided by the number that is in that sample. Multiplying those things together, add and subtract it from the proportion that you came up with. And very similar for the error, you've got the proportion for and against, the same critical value squared, all of that multiplied together divided by the error squared.